Hey Don, thanks so much for the wonderful introduction. Are you able to see my screen? If someone can just say yes in the general chat, that would
I
be
can definitely
perfect.
I can see your screen split in half. Yep, there we go.
Awesome. I did not know Danny's going to be here. If there is one person that inspires me, it's Danny. I can't say much enough about, just meeting him a few months ago, and then I see some of his LinkedIn posts, and every time I see one, it's very inspiring. I highly recommend following him. What a gem of a person. Having done conferences for last 15 years, I have a lot of respect for people who organize it. I know it's a lot of work behind the scenes, and a lot of times people don't get the credit. So, Don and your team, I'm extremely grateful to you for organizing this and having me here. It's definitely my pleasure and an honor to be here. I'm gonna try to do justice to this talk because this title is big, but that doesn't mean that I'm big. It's me just sharing some of the things that work for me, and I'm pretty sure I'm gonna learn a lot from you just with your questions, and hopefully down the line we are a big tech community all over the world. We connect over LinkedIn and meet at a conference. If you ever see me, please say hi. And if you find mistakes in my presentations, I would love any feedback that can help make this better. Danny gave me an amazing opportunity to speak for the first time at DevFest North America next week. I highly recommend joining this event. There's a ton of amazing speakers. I'm myself looking forward to learn a lot. So this is my story. I lived on 30 bucks a month for 7 years in India. I actually was pretty well to do, but I realized I had a lot of poor friends when I grew up, and I really wanted to see how it feels to be poor. After running a business that did extremely well, I started coding at the age of 6. I ran a business to help my local community at the age of 14. I was doing extremely well. And then I decided literally for the next 7 years to live on 30 bucks a month. And tell you, I had friends that did the same. And I tell you, we had a great life. I can't complain about anything. I think we had the best life ever. I don't think money defines what you do in life. We had a lot of fun. We did a lot of good stuff. So mantra for success, I only have three things: learn, grow, collaborate. And if you do all the three, success is yours. And by success, I really mean you're going to have a happy, peaceful life, and you're going to love creating things that will give you priceless satisfaction. Return of investment on something like that is just priceless. I don't have any computer, so I started coding at the age of 6, and it was interesting because I would get a computer twice a week for 30 minutes each. So I had to write code on paper. I'd go home, write code on paper, and it was interesting that if I had bugs in my code, even missing a semicolon or whatever, then I had to take some time to debug it, or let's say, compiler time to even build it. So I started getting better writing code on paper that I would not even miss a single semicolon. So I loved the fact that I didn't have a computer because I had to write code on paper. And in hindsight, that was the best thing that happened to me because that made me a disciplined developer, right? I was like a very nonchalant kind of a guy. I don't think I was ever disciplined. I was just random like a lot of other people are. But this, in one way, forced discipline in me. And in hindsight, that was the best thing that happened to me. And then, of course, when I came to the United States, lived on 300 a month. I had a great time in UTD, made so many good friends. Most of my friends today work for all top tech companies. Some of them have their own businesses. And we're all doing what we consider at least good karma and good work because most of what we do literally creates jobs, prevents thousands of layoffs, and help companies save millions and also make billions, which in turn helps a lot of other people in the world. And that's why I love the technical community because it's such an amazing thing to do. Like you get paid to learn, and I wanted something where I could learn my entire life. And then you see the right hand side. Left hand side is the same exact person. Right hand side is the same exact person, except I'm grateful that so many big brands like Microsoft and Google recognize me. I never thought, I would be ever be recognized by someone. Like who thought that Google and Microsoft would put their names in front of an individual? Never in my Never thought I'd write a book. I didn't think I was ever going to be an author at LinkedIn Learning or a keynote speaker, having Fortune 500 clients. And just so you know, the left hand side is the same exact person. So whenever I look at anyone, I see equality, nothing else, because just because the person on the left hand side lived for 30 bucks a month is no less than the person on the right hand side is the same person. And that's exactly how I want to look at people outside, is that they have a lot of potential. The next person you meet who's 10 years younger than you could be the next Elon Musk. You don't know who that person is going to be. So always remember that. And that's one thing that's worked for me entire life. I was very fortunate to be a judge at MIT, Harvard, UT Austin, UT, D, which is Dallas, and a lot of other universities. And I learned a lot of things here. One of the things, if you see on the right hand side, that's more than 1,000 people, MIT. And I was a judge and a mentor, and I spent a lot of time with them. And you'll notice they're not all from MIT, they're actually from all over the world. We even had people from UK, Africa, India, a lot of other places, and I spent time with them. So what I learned, number one thing, MIT says collaborate. And they're not just doing a hackathon, just MIT. They decided to bring people from all over the world. That tells you the Ivy League cares about learning from others. And they're not just an isolated people who think they're the smartest people in the world. They're, in fact, big on diversity. And when I say diversity, I mean diversity in thought process and learning. So I learned a lot here. Number two, collaboration was big. One of the best things about MIT was that these people were doing, hardware and software, and on a hackathon, it's not easy to pull it off, right? You have an Android app, but then you have a robot, and then you also have developers that are doing the user interface on the web and things like that. So that was very amazing to see that in action. So, coming back from from MIT and learning from a lot of other places in the last 10, 15 years, I decided to go back to UTD and create a CS endowment fund. And we were the first people to fund it. And if you look at these two people here, I'm so inspired by Dr. Gupta, who's right next to me right here. He took over UTD right after I left, and I was fortunate to have worked with him. But this one person decided to change UTD. We were ranked 73 at that time, and now in computer science, this school is ranked number fifth for, I think it's software engineering for undergrads. I think it's ranked fifth now, which is pretty big in 10 years. So how did Dr. Gupta do it? He collaborated. He brought in the alumni together, same as what Ivy League does. And then Dr. J, very phenomenal work he did was bring in actual experts from the industry, like me, a lot of others, a lot of UTD alumni, and a lot of people who were not even UTD alumni, and then started doing workshops. In our times, there were like 2 or 3 workshops in a year. In his times, you have sometimes 7 to 10 workshops in a week. See how two people can make so much difference, and all we did was support them, and results were phenomenal. The reason I say this is because all of you are part of this amazing community. You're doing this great work. The more you collaborate, the more successful we get as humanity and community. And we ended up at UT Austin Chancellor's home, and got a lot to learn over there. This slide, I want to make sure it's not controversial. The whole point here is in 2007, I was an intern making $20 an hour at Mary Kay. And my boss and boss's boss and every single person out there, even up to 10, 15 levels above, liked me. I had a great relationship with them in 2017. I drove, and I literally took, the top boss over there on a ride with me in Aston Martin, and he actually said that on LinkedIn, which means a lot to me because they love the fact that their intern did so well in life. And then, of course, there was only 2 sold in Austin, so it's the same person living on $30 a month. Makes no difference at all. However, if I can do it, anyone can do it. And then, of course, I made some good friends. You probably know of some of them. Me and my wife were there with Mel Robbins and Damon from Shark Tank, and of course Deepak Chopra. This is me and Microsoft Ignite. Literally, I think it was a couple of weeks ago, so it was definitely recent. This is my LinkedIn interview. I'm doing 7 keynotes thanks to Google Communities in 4 continents this month. And the whole point, again, is learn, grow, collaborate. So how do you collaborate? When people say network, I don't know if I really want to network. I want to go and give something first. I want to give something to the community and hope that they give me a feedback or a lesson or something that eventually will grow me. The point is collaboration is probably even more important than just networking. Networking alone, fine, it's a good thing, but how do we figure out ways to collaborate and take humanity forward? That's what interests me the most, and it's worked a lot for me. So then this morning, by the way, I delivered a keynote at 4 a.m. This was for my first keynote in Africa. So it was fun because the timing went completely off. So I got up at 3 a.m. and it was fun. A lot of things happened behind the scenes. I don't think attendees ever figured what happened, but this kind of stuff happened. And Rob, my friend, was also doing it at 4 a.m. from Arizona time. This is me in Vegas, and look how awful I am on taking pictures. Just a few years ago, this is a panoramic picture taken from iPhone. This is even worse as you look at it. I mean, so that tells you I'm so sloppy. I get things wrong all the time. So if I can do it, anyone can do it, right? And then, of course, there's a lot of other places, amazing community. I've got friends all over the world today. I'm so sloppy that this is actually London, and I think I said Germany. So think about that. If I could do it, you could do it. And that is London. And this is really not me. I'm actually right here, the 5 feet 10 inch little guy over there. It looks like a big guy up there. There's just a projection on the screen. So that was an amazing conference. Highly recommend going there. Great experience. And then another panoramic picture. Look at that, But look, technology's gotten so much better. Try the Pixel. Danny talked about that. I'm telling you, that has some amazing pictures. All right, that's our conference, MVP Mix. I've been running it for 15 years, and then also team of experts that over a period of time we ended up growing. You cannot do anything alone. I learned it the hard way. There was a time I was so serious about writing good code that I actually wrote code in more than 12 projects in a week because I was trying to go fix every single code that I could out there. Then I realized it's not going to work. The only way things work in the long run is you create a team, and that team takes care of bigger things, and you delegate and you trust them, you train them, and you get better. And after some time, that same team teaches you, right? One of the first things I do anytime I hire a junior developer is I ask that person, what is a framework you know or you learned today or in the last week? And you'd be surprised. A lot of times I've not even heard of the framework. Anyone in tech can teach you. Why? Because there's more that you don't know than you know. And this applies for every single person in the world. But when you look at a team, they could be an expert in something as a team, and an individual has a limit, but the team surprisingly doesn't. I was fortunate to have a lot of amazing clients, and hopefully this list will keep growing, and we've been very successfully helping them. Fortunate to have spoken all over the world and met so many amazing people all over the world, especially tech people. So that's some stuff. So you get inspired and hopefully motivated that a lot of this did not exist 15 years ago, and it started happening when I just decided to focus on three things: learning, growing, collaborating. I'm going to keep repeating that because that is the magic formula for success. So, how can I help you? Well, one of the things I've learned over a period of my career is extremely hard to find a person who is visionary and has attention to detail. It's interesting. And then there are two very big strengths, like visionary. How do you describe what a visionary is? I mean, in one way, if you look at it, visionary is a person that sees future before anyone else does. And maybe you are a visionary, and you know what's going to happen to you if you're a visionary and you don't know you are one. Most people who are visionaries, they actually think they're crazy themselves. Even Elon Musk has said that. But they're seeing something 5 to 10 years before other people are seeing. So most people will think of them as having a crazy vision, and they might misinterpret that to mean that those people are crazy, right? And that is why, if your vision is good, you will think you did well and you're successful. But at the same time, in order to get the vision somewhere, remember, everyone says that idea is not as important as the execution. And that's where attention to detail comes in. So today, my idea is to give you examples from algorithms, UI frameworks, DevOps, AI, and other things, including cloud. And the idea was that maybe you are one of these people. Like, let's say if you are good at UI and you understand algorithms, you don't have to know anything about AI, but I want to give you examples from all these different fields. So hopefully you can relate to it. And my whole idea is to show you how to be a visionary and have attention to detail so we can solve problems. I don't want to give you a checklist of 10 things that, hey, these are the things, read these books, there's 25 books you got to read and do all that. You can literally Google all of that information and you can get it. My whole point is to see if I can change the way you think. And if you're already thinking that way, that's great. And if you think differently, please let me know because I'd like to improve and learn more too. Here's an example of something that I read in around 2000s, actually. At that time, I first time learned that Average tenure of companies in S&P 500 in 65 was 33 years and 1990 was 20 years. And I didn't know what's going to happen by 2020 or 26, anything like that. But I kind of felt that the things are changing so quickly that this number is only going to reduce because you kind of see a trend going in a different direction. And then what was the catalyst? The catalyst in early 2000s was what was the catalyst in late 90s, which was technology. And if we did not keep in, changing and reinventing ourselves with technology, future would be really different. And then we saw that. We saw Blockbuster and a lot of other companies die. And there were some big companies, right? Like you never thought Blockbuster would die. And there's Lehman Brothers and a lot of others. However, if you look at everything else, technology was the big differentiator in the last 20 years, and it's only starting to get better. Now, next 30 years, we know technology is going to be a winner. Imagine that this came out, I think, in 2015 or 2016, and in 2020, the pandemic literally made a lot of companies digitally transform overnight. If they had not done that, they had to, and if they had already done that, they had an edge. And then just check the stock price of Google, Microsoft, Apple. They're all digitally transformed, and look what happened. It skyrocketed. I mean, who would have thought that $1 trillion company becomes a $2.5 trillion company? Google's more than doubled in that time frame. So this is interesting because if you knew this in 2015, 2016, what would you do? You do what we were doing, which is we were digitally transforming all our clients. And that was great because during pandemic, literally 100% of the clients that I personally work with did not have to have layoffs, which is pretty big. We didn't have to have layoffs. In fact, we hired more people. We helped a lot of people. There's a ton of people out of jobs, and we did constructive work just because we did things at the right time. We had the vision, and we also had attention to detail. Here's an example of DevOps best practices. A visionary can see DevOps taking over the world, and we were doing DevOps before the word was even coined. I think the industry was doing a lot of it, and words get coined later. I think the word came out in 2009, but a lot of this evolved over a period of time. There's at that time you did continuous integration and delivery, but in a much different way than you do it now. You didn't used to deploy services 5 times a day at that time. There were software. Even big companies like Intuit would launch a software once a year or upgrade a software once a year. Later, it almost became like we can literally go and independently scale our services, deploy them independent of others 10 times a day if we wanted to. But if you look at the detail here, what's more important? The important piece here is we have to have a nimble, agile organization that does continuous integration, continuous testing. But if you forget every single thing, a visionary will look at this as continuous improvement. And as long as you do that, whatever new comes up in DevOps, you're going to be able to handle that. And if you add that as part of your team's DNA, success is yours. And now it's the team's job to make sure they have attention to detail and continue doing the work. This is exactly what we did. And a lot of our clients were way ahead of the game in terms of scale, in terms of digitalization, digital transformation, working from home, security, and all those good things. Here's another example of solid principles. And this is, if you know solid, if you've done any object-oriented development, I'm pretty sure you know this. But attention to detail. In the last 10 years, my team has interviewed more than 20,000 people. And you'd be surprised that everyone out of these 20,000 people, for the most part, knows what solid is. Most of them can explain what it is. Most of them can give you examples. But it's interesting that less than 500 people understood Liskov substitution principle correctly. And the question we love to ask, which you can ask now in your interviews, is how would you test Liskov substitution principle? And think about this. Out of 20,000 people, only 3 people have answered that question correctly. Why am I bringing this up? This is an opportunity for you to know that even at that level with 20,000 developers, a lot of them very good, worked at top corporations, they may not have ever unit tested Liskov. And you know what? If you don't unit test Liskov, you can end up in a lot of problems. In fact, if you think about it, if you have an account and a checking account, a savings account, and you have some kind of inheritance going on, and you don't check for Liskov substitution principle test, you may end up creating issues in your code that might end up losing money for your customers. And if you're a bank, good luck. I think this is highly recommended. And it's, again, it's not, the point is not that, hey, always do solid, which you should, but, or you have to know this detail. But the point is that if you know something, try to unit test it, because that's the only way you learn it. And if you've not done a unit test on that, somewhere there, you may be lacking an experience. And if you do that, you are ahead of the game, and that's exactly what you want. And you can spread those good ideas with other people. Another thing that we notice is enterprise patterns. And some people end up learning enterprise patterns and they're great. But there's a big difference between principles and patterns. Principles apply all the time. If I have principles for object oriented development, as long as I'm doing C Sharp, Java, or any object oriented language, those principles will apply all the time. Patterns are specific to a single problem. These are great, and all of them have a lot of sub patterns to it. The biggest problem we see in the industry is that most people that understand patterns also start using it wherever they can. It's like someone with, what is it? It's a person with a hammer thinks everything is a nail. So just because you have the solution doesn't mean you have the problem, right? Like when cryptocurrencies came out, everyone just wanted to do blockchain for every single thing. Blockchain solves some problems very well, but it doesn't solve all the problems, right? Some things have to be mutable. They don't have to be immutable. So that's one thing that I always recommend is first learn the patterns, understand what they do, what problems they solve, and then eventually start solving them. And once you start solving problems, you're going to realize that they all have a different use case and they make sense where they make. And sometimes even the very well-known patterns may be implemented incorrectly. For example, repository is a pattern we see very few people understanding. I can't talk about much about it today because this is a very high-level talk, but that's just an example. Now, magic formula, very simple. It is learn, grow, collaborate. And once you do that, you create a team. And that team can beat anyone in terms of delivery because it's very easy to deliver good software with high quality and less time. If you learn, grow, and collaborate over a period of time, you have a lot of IP. And there's an example on our website where the client has 300 users. IRS pays the client 300 users for about 27 years, and a lot of banks purchase their software. It works really well on Windows. And they kept failing to go to web for 14 years. And all they had were 108 components. Kasten came in and 40 components were done in just 1 month. Even the client didn't believe that. So when we said, hey, you got 6 weeks left, we can do it in 6 weeks, they didn't believe us because we said we can do it with 5 people. They thought it's going to take at least 20 people. And they went to a lot of companies and countries, and different companies in different countries told them they need at least 6 months or more because that's what the minimum they wanted. And they also thought that it's almost impossible to do it with less than 20 people. And that success story is out there. I highly recommend reading it. But if you have IP over a period of time, you're learning, growing, and collaborating, you can speed up things. When you speed up things, cost goes down. And if you're doing high quality software, you won't have much technical debt. And that will also drive your cost down. So when you talk about cost, quality, time, people say it's a triangle. You can only have two of it at one point of time. We disagree. I think you can have all three, especially with folks like yourself that are very technical. You can do it. All right, something else. Whenever it comes to frameworks like this is a slide. It's not really my slide. Long back, it was a pretty famous slide. Everyone was talking about it, and it is good work. And this is, I think, 5 or 6 years ago when I bet Angular 2 was launched, and they're comparing these frameworks. Now, looking at this slide, you'll go, I'll just pick React. Looks like it's pretty good. Now, that sometimes happens, sometimes decisions get made like that. Sometimes they go, well, I just like the syntax. Let's just pick it up. However, there's a lot of things to consider. One, React at 139 KB was just a view library, and there's other things you needed from outside, and there were libraries done by the community. So that number may not always apply, right? By the time you have an actual app, that number could go bigger. Angular, on the other hand, may have a bigger size. It was not because it was wrong or bulky code. It was more because it had more functionality. But the part that's interesting is that it had tree shaking capabilities. So you could even launch an Angular app with less than 100K if that's all you used. Number three, if you're a line of business app and you're making an app for let's say 100,000 users that are working for your company, understand that this is a single page app framework. This is just a one-time load. And that literally on your internal network could be less than half a second. So does the size even matter, right? Angular was launched with TypeScript. That has a lot of advantages. Danny has put on his LinkedIn a very beautiful, I think it's a 5-6 line thing about why TypeScript, and it makes sense. And a lot of people will agree. Google, Microsoft, a lot of companies use it, and they made TypeScript first-class citizen, which helps reduce a lot of bugs. That said, React has pretty amazing, community, and it also makes a lot of sense. And at that time, we realized that React was backed by Facebook and Angular was backed by Google. So we decided to do both of these frameworks, but depending on our clients' needs, we said, check, what is it, React for one, and maybe Angular for another, totally depending on their use case, their teams, their style of coding, what all they preferred, things like that. At the same time, we also knew that Ember's pretty good, except the community had shrunk a little bit, and we were right, because in future, all that matters is community, and Ember had the least amount of traction out of all of them. Aurelia did well in certain use cases, and we used Aurelia here or there. Polymer's another great framework, but for some reason, Angular got picked up more by the community, and you kind of knew what the reasons were, and there were a lot of reasons. Don't want to get into that detail. But again, what I'm trying to get to here is not comparing frameworks. It's about how we compare frameworks and things that matter. And what I just talked about is just a few reasons. And you know what happened? Companies spend millions and millions of dollars doing the same POCs on a lot of these frameworks again and again. Whereas people like us had already done these POCs before we even went to production with a lot of companies. And we actually created multi-billion-dollar apps that actually generate billions of dollars of revenue in incredible speed with something like Angular as well as React. And let me show you something real quick, right? Have a look at this. This is Fibonacci recursive, and it took about 1.6 seconds. And the value is this, which is the same value as this. And if I run this example, it's almost 0 milliseconds. It's extremely fast. And then just so you know, right, I don't have a lag or anything here. I just want to show you the source. The source is very simple. It's a Fibonacci. If n is 0, return 0. If n is 1, return 1. Otherwise, return the sum, because Fibonacci numbers are 1, 1 comma 1, right? That's 2. 2 plus 1 is 3. 2 plus 3 is 5. 5 plus 3 is 8. And that's how the sequence goes. So it's a very simple solution. Fibonacci of 40. That's all it was. Fibonacci of 40 takes about 1.6 milliseconds. Not very good, because this is all on the UI, by the way. Did not even make a call back to the server. Now look at this. Extremely fast. Almost 0 milliseconds. Let's just say 0.1 milliseconds. And it's only being called 39 times. Whereas this method was called millions of times. What is it, 331 million or something? Something big. And this is only called 39 times. So let's look at the source. All right. In this case, we use a technique called memoization, and we create a memoizer. What it does is it's got an array, and it says, hey, if I already got the number for that particular number, ignore it. So now the calls are only 39. So algorithms matter quite a bit. You could have used any framework, but if you don't have the best algorithms, that framework would be slow. And it's easy to blame it on React or Angular, but a lot of times it could be our own code. So that said, still, performance-wise, they all had different repaint performances, and this was important. There's some third-party benchmarks that you could have looked at. These numbers have changed. This is an old slide 5-6 years ago, but I wanted to show you this because at that time we figured, for a lot of reasons, we could use different frameworks, right? If it's a gaming application at that time, I would have been more prone to go with Aurelia or Angular because they were on the higher end of performance, right? And React, as I understand, after a few years we checked and think it was 80 at one point of time. So things get better over a period of time. But keep in mind, anything above 60 is not bad at all. So sometimes for line of business application, that also might not be a criteria to use one over the other. But these are some examples, just wanted you to know. Having said that, we want every developer to understand what a critical rendering path is, because it's really less about your framework, more about how you do those renderings, because the DOM and the CSS object model can be changed by JavaScript, and that's why JavaScript is blocking. It not only blocks, it executes and parses. That's why it delays things. And then you have the render tree. And if you call layout and paint once, your application is extremely fast. If you do it multiple times, it can slow down quite a bit. So I'll show you an example of this. If you have async, the good news with async keyword is it executes when it's ready and it's happening asynchronously. But if you put something like this right up there, it blocks, then parses, then executes. So it slows you down. So it's a good idea to put most of your JavaScript right here, right above the body tag. And if you still have something critical, you definitely want to put it up there, because let's say you have a functionality that searches your website like Amazon.com. Well, you want people to be able to have search before the page is ready. So in that case, just the search functionality, that JavaScript that starts the API call, can be made available up there. So that's called critical, script. Older browsers, the way they used to work, according to Steve Souders, is that they used to get this internal, script. They would get an external script, JavaScript, whatever, download the whole thing, then parse and execute. Once they're done, then they pick up the next script. And imagine if you have a bunch of scripts, they'll keep doing that until finally they get to CSS images and download them. Browsers got smarter later, so they decided to have download the scripts, but then they'll still wait for them to parse and execute. And when all of them are done, that's when you have this. And these things change with HTTP 2, but with HTTP 1, that's why you had bundling and things like that, because you wanted to reduce those scripts. And of course, you have parallel downloads, so you want to take advantage of that too. Gmail Mobile did a very amazing job of making sure that they don't pay for functionality. Like, you remember whenever you have JavaScript, first thing you do is you download, then you parse and execute. But you only parse and execute code that is uncommented. So Gmail Mobile decided that, hey, look, most of the people on web mobile are not composing emails. They only look at the emails, they read emails, and then they reply to it. They never really compose. But if they do hit compose, in that case, they would uncomment this code and then eval that code. Why would they do that? That's because if this code is commented, you're not paying for the parsing and execution of compose functionality, which might be 2 or 3 people out of 100 doing it. But the first time you do it, you eval, you basically uncomment and then eval, which is a good idea. Remember, a lot of people think eval is not good, which is great. I understand that. Eval is not good if eval is done on other people's code or some kind of dynamic code. But if it's your code, eval is not bad at all. It's a one-time hit, and after that, the code has been evaled, so it's already there, so you don't have to do it again and again, and it's already been uncommented. So these are simple techniques that you can use to speed up your applications, right? So Angular is great, React is great, a lot of these frameworks are great, but when you do write your own JavaScript or TypeScript, these are some things you can use to your advantage by understanding how browsers work. And I'm pretty sure most of you know what this is, but I wanted to give you some examples. So JavaScript blocks CSS, object model, DOM, because it can change the document object model as well as CSS. So those are some things you need to keep in mind. That's why you need to avoid document.write, because that will be a blocking call. And then, like I said earlier, critical scripts should be up in the head and everything else towards the end of the body tag. Layout and paint are the most expensive operations on a browser. And I wanted to show you why that matters. So take this 60. Ilya Grigorik has a very good YouTube video about this, and I highly recommend watching his videos. Amazing person, works at Google, and does a great job helping community. 60 frames a second is about, in a second means 1,000 milliseconds. That means you have about 16 milliseconds to render a frame, and browser needs about 4 or 5 milliseconds out of that. So if it exceeds, your operation exceeds 16 milliseconds, the frame is going to be dropped. Now, theory says that you have code, GC, which is garbage collection, layout, and paint, but not necessarily in that order. And this is the theory. A frame should have this. However, if you write code like the right-hand side, you notice what's happening? Code, layout, again and again every single time that for loop executes, and then finally paint your frame has been dropped. Chrome and Chromium both have tools that you can see the frames being dropped. I highly recommend doing it over the weekend. You will see top websites in the world dropping frames right and left. All right, enough about UI. Let's move to the backend. Now, the backend, one of the most important things with the backend is understanding that we should not ever be religious to a tool like RDBMS. A lot of times, especially 10 years ago, it was a big, hard problem to go to a DB and say, look, we don't need an RDBMS. And they were just not open sometimes to a NoSQL database. But the chart here explains to you that after some time, you just cannot scale it. Your performance won't increase at all. Whereas with the NoSQL, it's always flat, means you can scale it out. You can put any amount of commodity level servers and you can grow the NoSQL database. Whereas a relational database, there's only enough memory and RAM you can have on one machine. And after it gets to a point that you don't get any significant benefits, let's say you double the RAM and you double the CPU and you put millions of dollars on a server and you only got like a 10% benefit, right? Or maybe 5% benefit. So that is going to happen with the volume of data at some point of time. That's why it makes sense to use relational as well as NoSQL databases. And why is that important? Because this is a triangle. A relational database can have consistency and availability, but they're not easy to partition. Whereas a NoSQL database can have availability and partitioning, but they're not consistent. They're eventually consistent. So they solve two different problems. And most of the websites today, especially the ones that need scale, need both of them and even more than one or two, because there's actually examples of that. By the way, I'm not going to get into this, but if you are going to get into distributed programming, definitely read Fallacies of Distributed Computing. I know it's a lot in one talk, but keep in mind, right? Software development, anything to do with software development, including big data, AI, cloud, microservices, whatever, it's a growing field. And the only way you can be successful is if you're a lifelong learner. And that's why I wanted to show you all these things, because I've learned these things over a period of time, but I've also spent time and money and have a lot of experience making it work with a lot of corporations. And over a period of time, everyone can get there as long as you're open to learning and growing. So here's a chart that explains relational databases. You have the most functionality in a relational database. And document databases are pretty close. They have a lot of functionality. They may not have reporting, right? And that's not the best thing for them. They may not have ACID guarantees. They may try to have a flavor of it, but relational is always going to be better on that regard, except when it comes to scale and performance. These are way faster, and a key value pair is way faster than a relational database, right? So you look at the y-axis. However, if you look at the x-axis, key value pair is like a memcached, and that is pretty low in terms of functionality. It is literally a key value pair, a bunch of strings. And if you add some, let's say data structures to it, you have something like Redis, and then you have Google Bigtable and other, column family kind of databases. You have search engines, Elasticsearch, Solr, Lucene, and then you have document databases like React and all, and then graph databases. So they're all doing different things. They're solving different problems. It makes sense to use either all of them or a few of them to solve your different business problems. Like Redis solves a great problem, caching, and does it extremely fast. It's got PubSub. You can definitely use it, right? You can use Postgres for ACID guarantees. You can also use a document database for, let's say, a lot of blobs and comments and a lot of that kind of data. And you can use search engines for searching on a website. It's incredibly fast. Let's talk about caching. Whenever you go from one server to multiple servers, a lot of times your caching is done in memory. So the problem with that is you make a request. First time you make a request, goes to the database, comes back, and the server goes, okay, I'm going to get that response and cache it right here. What if you get a second request? Well, this time the data was already changed here. So you have version 2 of the data on the third server. What if you get the third request on the server number 1? This is stale data, so your cache is invalid. Well, a lot of people are like, well, I'm going to go to the database, check if it had the latest database, data. Then only I'm going to give the user this back. Well, then you defeated the whole purpose of having a cache. And you'd be surprised, this is code we see all the time. A lot of smaller teams, smaller startups start like this, and when they scale, It's a hard thing to scale. So what do? Well, you can simply use a scalable, auto-scalable shared cache agent like Redis that knows how to scale it, and you can keep all of that here. It's going to be in RAM, and any of these servers, you can have 300 of those servers, 500, doesn't matter. They can make a call right here and get all of that data in memory, and it's extremely fast. When people start scaling RDBMS, they end up coming up with an architecture like this. It's very well known in the industry. It gets extremely expensive, not in terms of just performance, but also in terms of pricing, because you end up putting a lot of servers and you're eventually not getting that benefit. Imagine what if you have to get data from both these servers. It's a cross join, extremely hard, and it's going to be slow. Imagine a cross server join is slow. This is a cross cluster join, extremely slow. And this, at the bigger level, is a set. What if I need data that is a combination of both the sets? Now I have a cross set join, and that's extremely slow. And over a period of time, this wouldn't scale. Previously, we saw most architectures were like this because they were trying to solve the wrong problem. The problem was scale the system, but they try to solve the wrong problem, which is scale the RDBMS, which is really not meant to scale. It's meant to scale up, but not scale out. So going back to first principles, right? If this doesn't work on PowerPoint, it's not going to work in real life. Now, the inverse is not true, by the way. Don't say that if it works on PowerPoint, it will definitely work in real life. That's not true always either, because sometimes we may miss something. But we know that if it doesn't work on a slide deck, it doesn't work in real life. So this is one way we can solve problems. And one way to do that is what we do. We always look at how can this project fail? How can this architecture fail? We try to deliberately fail every single thing. And that's our definition of architecture, right? I mean, it's same as what you do in debugging, right? You're deliberately trying to fail your program again and again until oh, we don't know of any other ways this will fail, and let's go to production. So here's an example of something that simply scales very easily. You're Amazon.com, someone makes a search query, let it go to an auto-scale search database. We can scale it to thousands of servers just because it's an auto-scale Elasticsearch, Solr, or something similar. And then if you want to know more about the details of the product, let's say you want to buy a 24-inch monitor, AirPod, or Google Pixel, whatever you want, you now want to read the description of that product. All of that can come from a document database. There's 5,000 comments. They all belong right here because this is easily scalable in terms of documentation and data. So you can put any amount of data here. I can easily scale. You have a Redis cache. You can bring some from there. You can have a CDN for your images and things like that. And you can still have an RDBMS for important data like orders and customers and all that kind of stuff, right? Payment information, all that. And you would never need to have a cluster because most of the data that was supposed to belong here belongs here now. It's taken 80% of your data right there. And all your queries are coming from here. So the traffic to this is negligible. It's less than 5%. So you'll never need to go beyond a certain size, and you probably never have to have a DB cluster, no matter how much you scale, because the scale is being taken over here, here, as well as here. So that's a way to get around the problem. And finally, offline processing. Why? When you go to Amazon.com, they say, hey, your order's ready, good to go, here's your ID, we'll talk to you later. In the last 10 years, I've noticed a couple of times, I've got emails, hey, your payment didn't go through. So I'm like, how did they say that the order was fine? Turns out they probably do it behind the scenes. And I think that's a great idea because they did not waste my time as a customer. They told me very quickly, my order's ready, here's my ID, go. And if in 10 years they have a problem with my credit card, I can always go back and add a new credit card and I can get an email for that and I can do that, right? There's no point slowing the customer down. So if you can make something offline, that's something I would always do. And this is one thing we always ask our customers, do you really have to have it real time? You could do it offline or you could do it in a different way. So there's a lot of attention to detail here, but also the big picture. There was no book that had the big picture, so I decided to write a book. I want to be 100% clear. I have no incentive to sell you my book because all the money go to charity. But if you can't afford a book, I highly recommend asking a library to purchase the book. And also, I would love to give you my author discount. That means I will get $0 on royalty. My whole idea of giving this book is to spread the idea so you can learn. I really don't want to make any money off of the book, but I'm okay with my publisher making money because, of course, they are in a business. I don't do this for business. And the book on the left-hand side is way better than my book. It is one of the best books ever written on algorithms. It's about 1,300 pages. Mine is about 173 pages, and if you cut down some pages, you probably walk away with a weekend read. But they're completely different books. This book is something that's going to give you a big picture that literally puts you ahead of 80% of the developers out there that may not understand big picture. And developers who are really good at algorithms should definitely read the big picture book. Now, on the other hand, if you are very good at big picture and you know that, don't worry about this book. I highly recommend reading the algorithms book because that will help you get attention to detail. And keep in mind, I've read this book multiple times in my life, and I keep going back to it every few years so I can hone my algorithmic skills. Now I'm going to talk about examples that are not in that book or even my book. So one of the ways we scale is understanding what data is and how we can solve problems differently. A lot of times we expect everything to be an ID, but if you look at from a user interface point of view, the user never knows the ID. They usually know other things. They could basically say, I want to drop down of all the states, and from that state, I want to pick a department. I want to go from there. They look at it differently than we do, and we're pushing everything in terms of ID in the database. But if you can scale out, then you can have different versions of data. Like for example, in this case, everything is by the state, and I got all the IDs over there. If I have the ID, I can get the details, but my query is going to be the state. What if I have another table that actually goes by department, right? What if I have another table that goes by zip code and things like that? It makes a lot of my lives easy. Now, this doesn't have to be a table. This could literally be a document in a NoSQL database. And keep in mind, it's completely okay to duplicate data in a NoSQL database. It's just a different representation of data. Why do we do relational databases? Because relational databases were normalized. Why were they normalized? The reason they were normalized was because they wanted to reduce the duplication of data. Why did they want to reduce the duplication of data? Well, the real answer is because they couldn't scale out. If they were able to scale out with commodity level machines, they would not have worried about duplicating data. And this is not duplicating data. This is a different representation of data. They didn't want that, so they came up with normalization. They came up with joins, which made sense then. And most of that was done in the 70s, right? Most of those algorithms were written in 70s. Scale came in later. We got iPhones, we got Android, we got everything, we got IoT, and now we have way bigger scale than we had 20, 30, 40 years ago when those patterns were made. So it's completely okay to have different representations of data. And this is how we speed up websites, processes, and make lives easier. And if you make your client 250 milliseconds faster than your competitor or their competitor, you already made them win. Another example, I saw this with my eyes with a big hotel chain. They used to make a query and do a join with the countries and get all the states and then get the cities and the properties and then the facilities. For something like this. This is all the CEO wanted to look at. Hey, can you give me the property and the facility ID and things like that in that area? What if you wanted to search through a zip code? All those joins or multiple hierarchies of picking that thing wasn't really important. Really, in this case, it was a drop down first, then another call to all the states, and then you pick another state, and then you go to the city, and then you put the property. And imagine there's 4 different drop downs, and then you got the facilities, right? It's a lot of calls back to the database. Really, we just give them a text box and says, search whatever you want to search. And the next thing that shows up is this. This won't even take 15 milliseconds. And we did more than 2 billion hits a day for a client of ours. And the max hit was 11 milliseconds. We knew nothing was going to go more than 15. That was pretty incredible. But most of these websites have anywhere between 6 to 8 second SLA. And that's a serious number. Imagine that versus 15 milliseconds on the server and then add the latency on top. Just a very different representation gets the things done. Another one, composite keys. A lot of people do that in the databases, but it's probably a very good idea to do something similar in a NoSQL database because now you're using order of constant. This is not even an order of n. Even that will require you to go through a loop. This is exactly an order of constant. You can have, worst case, you have a hash table and you can get everything back from that pretty quickly. So you combined your 2 different keys, actually 3 different keys, and created a composite key, and it scaled extremely well. Here's another solution where if you wanted to geolocate data, all the cloud behind the scenes, geolocate data, right? They give you co-location of that data if you do your IDs correctly. Now, with grouping the right way, you can do it. Now, they may give you the option to do it, doesn't mean you probably are taking advantage of it. What I would like to do is figure out a strategy, and we've done that for our clients, that we are able to co-locate users' data. And let's say you're in the southern region in Texas, you should be able to ping the Texas server. And if you are in California, you should be able to ping the West Coast server, which makes perfect sense. If your IDs are done smartly, you could come up with ideas like this and now have the least amount of latency for your customers. And we've done this a lot of times, works very well. Inverted search, another good one. You know what it is. You've always used it. Anytime you read a book, you go all the way back, there's an index. And in that index, if you look for a word, it tells you, oh yeah, that word is on page number 30, 75 and 182. That's exactly what we're doing here, except it's just a little different implementation and representation. And you can do it in multiple different ways. And this will speed up your queries, because some people might want to just search via department or someone via city and things like that. Having a look at this, if I were to ask you what data structure that is, can anyone answer that in the chat? I mean, do you think it's a graph, it's a tree, it's a list? And what do you think it is? If you are able to do that, I would highly recommend it. I can't see the chat right now, but I'm assuming some of you already said and gave your answers. Now, don't be disappointed, because I know you're all smart people. The issue here is the architect, which is me, made a big mistake. I should not have done it this way. The representation is a little incorrect, because it is really not a tree. Let's look at it a little differently. What it really says is LCD Samsung TV or LED Samsung TV. So it's really a part of a bigger thing out there. Or look at it differently. All the Samsung TVs are on server number 3 and 4. All the cell phones are server number 9 and 10. There is no tree. If it was a tree, then you would have to go from one server to the next, and that's how you would end up here. They're all different servers with HTTP addresses. I can make a call to them. You can do the same with containers. You can have Docker containers. You can run the whole thing. So just because an architect may have a different representation, this may lead the developer to create a tree, which is going to be an order of n log n, which will slow you down, whereas this is an order of constant. As long as your hash map knows where to go, it's just one call. Another representation of the same exact thing, nested set. Really, it's not a tree, it's a nested set. And that's why a set, as you know, is the easiest thing to query, is the fastest to query. Another thing we see all the time is JSON. And with JSON, depends on how you use it. A lot of times we see code like this. Now you have skills, and that says Azure, GCP, Spark, Spanish, whatever, right? Now, then you have a level, and that says, hey, with an expert. Okay, so you're an Azure expert. Okay, you're an expert in Spark. Oh, then you're Spanish. Now try to do this in code. It will take a lot of time. First, you're gonna have to split the whole thing. Then you're gonna have to split this. Then you're gonna have to get both of them in some kind of key value pair. I think the easier way to represent that is something like this, where you all know what that value would be, and this is actually a key value pair. Just because it looks simple to use doesn't mean it's the best algorithm. In fact, this may not look as simple, but in the long run, it's going to give you way faster retrieval. And on JavaScript, every single millisecond counts, right? We actually were working on a Fortune 50 client, and they literally wanted to rewrite the entire application, and it was going to take them 2 to 4 years. After 6 years, the application was not doing very well. SLA was really bad. It was somewhere around 20 plus seconds, not milliseconds, sorry. Yeah, 20 milliseconds would be awesome. And we decided that we could rewrite a lot of it. And we used a lot of these techniques. And the first thing we did was take a function that was taking 852 milliseconds on JavaScript and was called 1,600 times. We first brought it down to 3 milliseconds. And the next thing we did was, see why it's being called that many times, and then reduced it to less than 100, I believe. And the entire sales cycle went below 5 minutes instead of sometimes being 15 minutes to 1 hour. That's how much difference algorithms can make. And again, these are some things that, our ancestors have always figured it out, and we just have to find the right problem and the right solution. All right, without getting too much detail on machine learning, what I wanted to show you, a 3-minute video on YouTube that you can watch for yourself. It explains how I got here. But this is TensorFlow.js. Smart people, amazingly smart people, created TensorFlow. You can use it on JavaScript. It works incredible. And then the way it works is this is the data set. And if you take even a 10-year-old kid and say, hey, what kind of data set is this? It'll that person will create something like this. Whereas AI without training does this, and after training does something like that. So this is what the AI does. I changed their code and I ran my own AI. And as you notice, every single step is now visible. Not only, in this case, you saw what the final output was, but in this case, you can actually see that I'm even showing you how the AI gets there. It actually keeps getting better with every iteration. And this is a little better algorithm. So you'll see this going all the way as a curve. On that side, you don't have a big curve and you don't have a nice curve over here, right? So keep in mind, all I did is innovate on their own code from their website, and there's a YouTube video that shows you that. So when people tell you that something like AI, you can't predict what it's going to do, I don't think that necessarily is true. So there's always ways to improve what we come up with, and I love TensorFlow JS, and I love TensorFlow people, whatever they've done. And once I contributed, I sent it back, and some of them even reached out to me, and that's how I made friends. So you see, simple contribution like that can make you friends from teams like that. All right. I think we're almost close to this, but in short, there are some of these free reports that are available on our website, which compares a lot of the AI done by Microsoft, Google, Amazon, and others. And what is really showing you is that in this case, Microsoft has 2 errors, Google's got 31, and Amazon's got 100, whereas Google's got 4 errors here, and Microsoft's got 19. So you see, there's some opportunity to make these solutions better, and you can do it with all the three teams out there, and they're the finest companies in the world. And if you can make their products better, well, then your confidence level is going to be high, and eventually you probably work with some of these people, and you can help tons of other companies out there. So this is to show you that tech is such a growing field that everyone's going to make mistakes, and they're all going to get there. Like my favorite example is quantity. Microsoft gets it wrong, Google gets it wrong, and Amazon gets it wrong. And it's just probably the simplest thing. But keep in mind, they have all these other things in an invoice recognition. They do a phenomenal job on the hard things, right? So there's always places where you can contribute. There's one bug you can find that no one did, and all you got to do is think of contributing. And there's more examples. I want to skip through all of that to go to my favorite slide, which is life lessons. And towards the end of the talk, I just wanted to share this with you. I've had very poor days, and I tell you what, those days created empathy in me. And I could go back and live with anyone, all the poor people, spend time with them, learned a lot from them. They knew a lot about lives. A lot of them were not poor because there was nothing wrong with them. They didn't have opportunities, timing was off, things can happen, bad things can happen. When I lost my parents, the next day, I found that two kids, 3 and 4 years old, had lost their parents. I mean, I was 33 when I lost my parents. I was feeling extremely bad. But the next thing I feel is like how bad their life is. And literally, I spend the next few hours making sure that their grandparents meet them and these kids are taken care of in my hometown in India with other adults that were neighbors over there, right? I completely forgot that I lost my parents. So see, anytime you think you're having a hard time, understand there's millions out there that are going to go to sleep without food tonight. Have empathy for everyone. Number two, days of sickness rekindle mortality. We're all gonna die. I mean, let's just do good things and make the best of what we can do. We're not immortals. We're not that important. We think we are, but at the end of the day, the world's gonna work without us. So why not contribute? Leave a good legacy. And then finally, days of failure rekindle hope. And I don't believe in bad days. I think all bad days were my best days, and I had great health in my bad days. Adversity is your best friend. It will teach you the best, and it's actually you'll surround yourself with the best people in your adverse times, right? My wife, I met her at the worst of my life. I mean, I lost my parents, things were not going well for me, and she came in at a great time. And that is going to be one reason we're always going to be best friends and probably the best couple that I know, right? But it is because of the bad times that she was part, psychologically with me. It makes a huge difference. Remember, curated content. This is a big problem with our generation. So all your negativity towards others will go away if you understand that they are a victim of curated content, exactly like we are. We're all reading things we believe in. So we sometimes don't understand other people's perspective because everything is curated. So just remember that, and let other people, fail. Give them the freedom to fail, like we give ourselves the freedom to fail. We're not important. Our contributions are important. Do not follow money. One mistake. I know a lot of people do that. Follow skills and good karma. Money will follow you. Remember the mantra: learn, grow, and collaborate. And finally, the most selfish thing you can do is help others selflessly. I wanted to do keynotes in countries I'll never have a business in. I wanted to do keynotes in countries I've never been. I wanted to do keynotes in continents I've never been. I wanted to meet people I don't know. I wanted to help people I don't know or I'll ever never meet, because I wanted to do it selflessly. And I'm so glad that I met literally strangers that are amazing people, like Dawn and others, and even Danny. We're all strangers a few months ago, and we're working towards a cause we believe in, which is way bigger than us, and we're collaborating like we're brothers and sisters. How amazing that is! This is why the return on the last bullet point is priceless. And so, thank you for having me. I really appreciate the time here today, and I hope I mean, I don't know if you have questions for me, or I think I'm already over time here, but thank you again for having me. And if you have any questions, reach out to me over LinkedIn. I'll definitely answer any questions I can. Thank you so much.